So this is the LLM 101 session, and we are going to take a brisk look at large language models, and we're going to do so in kind of a hopefully fun and interesting approach. Let's talk a little bit about what a model is. A model is an algorithm, so a bunch of computer functions and stuff like that, combined with some parameters. And the parameters in machine learning, which we're in the machine learning world, the parameters are learned from data. In a large language model situation, we're going to have something like this. We've got this, let's say, this huge corpus of data, all these different books and texts and documents, or maybe router manuals and switch manuals and Wi-Fi manuals, or maybe configuration manuals and documents, or maybe storage, customer incidents and case studies with responses and fixes and stuff like that. So whatever kind of corpus of information is relevant to you and what you want this model to learn, we can feed into that model and it can learn from that data. And so before the model has been trained on any data, if you said, hey, model, I want to ride my, and you gave that to it as a prompt, it might say strawberry, right? Just come up with some random thing because it doesn't know anything. It's just an algorithm with no meaningful weights, right? No meaningful learning. The learning is in the weights and the parameters for the model. And so it just randomly emits something within the mechanics of its structure. And so we say, well, hey, the right answer was bicycle. And so what we can do is we can go back then and we can do this process of looking at all of the weights that the model had, which to start with are just random numbers, and we can bump them all a little bit towards having it predict bicycle as the next thing anytime somebody says, I want to ride my. And so not all the time, I want to ride my skateboard might be the next word, right? But hey, it is more likely that it's bicycle than strawberry. So let's move the weights a little bit towards bicycle. And so time after time after time, we keep training the system on all the different possibilities, and it learns what are the likely things that are going to come after I want to ride my. But it learns a lot more because it's got many, many layers. There's billions of weights in a lot of these models. And so they can capture nuance and sentiment and semantics and all these kinds of very interesting things. And they get to the point where they can generalize. So maybe we trained it on, I want to ride my, and the answer is bicycle. And now we say, I feel like getting some exercise. I'm going to go ride my, and we want the model to make a prediction, and it says bicycle. Hey, good, right? It wasn't the exact text that it was trained on. That's called generalization, right? We want models to have the ability to generalize. So when we fit the models to the data set, we want to make sure that the predictions have the ability to generate general, case answers without only working on the data it was trained on. Now, there are scenarios where the only thing that this model is ever going to see is data you've already got. Well, in that case, you want to fit the heck out of it, right? You want to make the model really learn and memorize that data set as best as it can so that it always gives you the answers that are from that data set. But that's not usually how we use LLMs. Usually we want them to be generative, to be able to come up with new outputs because it's combining all of the learned knowledge from all of the different data that it's seen before with the context that you've provided it, right? Because you might not just provide it, say, for example, a instruction, you might also give it some information. You could say, for example, here's the documentation on this router. How do I set up a default route? And it could then use its knowledge, combine that with the context that you've provided, and do some very interesting stuff. All right, so that's basically the idea of a model. A model is a set of algorithms or technology that have been trained on data, and those weights, the parameters inside that model are what make it interesting. All right, and make it a model.